Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and we are discussing about the sequence stratigraphy of carbonate depositional environments. And in this particular lecture, we are going to discuss about the transgressive systems tract within the carbonate depositional environment. Already we have discussed about the other systems tract like the HST, the falling stage and the Lustern systems tract. Also we have discussed about the drowning unconformity, which is a very special characteristic feature of carbonate depositional environments. So, as the last part of this discussion on the carbonate sequence stratigraphy, we would like to understand what happens during the transgression. And this is a very important part, as during transgression the carbonate depositional settings, the carbonate depositional environments, they behave in a very different way, particularly if we try to compare that with respect to the siliciclastic systems. So, during the transgressive systems tract, the transgression process that can represent another major turnover point, major switchover point, where under certain conditions the carbonate factory can shut down again. So, already we have seen the carbonate factory can shut down during the falling stage, but along with that, along with the falling stage, we can also get a shutdown phase during the transgression. So, when that kind of shutdown takes place, commonly we call that kind of condition as the formation of a drowning unconformity, which we have discussed in our previous lecture. So, in general, transgressions in the carbonate depositional environment commonly is a threat to the carbonate platform, is a threat to the carbonate production, because the rate of base level rise are at much higher rate, commonly they are at higher rate than the rate of aggradation along the shoreline or along the shelf area. And when that rate significantly exceeds the rate of accumulation of sediments, what we get is more deepening of the water level, more deepening of the sea level, and that can lead to the accumulation beyond the photic zone, and that will stop the accumulation, that will stop the production of carbonate. So, when such base level rises during the high strength stages, that is always producing, that is always creating accommodation for the platform growth. But when the rate of rise of the base level is relatively low, it is overpacing the rate of sedimentation, but overall the rate of rise is low. In such cases, the carbonate platform can grow up gradually, and when it tries to maintain a balance, as we have seen in case of HST, a balance is maintained, producing a keep up phase. So, here also we can expect such keep up condition with respect to carbonate platform growth and the accommodation created. So, that requires the rate of rise of the base level should be slow. If the sea level is getting deeper rapidly, and as a result of that the photic zone, it is getting confined into the upper part of the sea only. In such cases, the platformal area where carbonate production is going on, that is no more getting the photic zone availability, and we consider the platform is drowned and the carbonate factory is shut down. If the platform remains within the photic zone, when the rate of rise is slower, rate of rise of the sea level or base level is slower. So, instead of deepening, which is continuing in the basin, but the rate of deepening is slower. So, in such cases the platform tries to maintain remaining within the photic zone, and if it can be there, the carbonate factory will survive through the transgression process. And in such cases the production of the carbonate sediments that will continue, and eventually that production of carbonate sediment, the accumulation of the carbonate sediments and the growth of the carbonate platform will catch up with the newly created accommodation. So, this particular phase is called as the catch up phase. So, earlier we have seen keep up phase, this is the catch up phase. So, during this catch up phase, the accommodation is created, it is created at higher rate than the production of sediments, than the availability of sediments, but the production of carbonate sediment is also continuing and it is trying to catch up, it is trying to maintain or reach to maintain that balance. So, this kind of condition, if it is prevailing, then during the transgression we can get a continuous carbonate deposition, and finally as we reach to the HST, as we reach to the transgression and high stand boundary, there the rate of accommodation creation gradually decreases, and then this carbonate production, the rate of carbonate production reaches to that balance position, and from there on it continues with the keep up phase that we have seen in the high stand normal regression phase. So, depending on what is the rate of creation of the accommodation during the transgression, it can be determined that whether the carbonate production will continue and it will continue in the catch up phase, or the carbonate production will stop and the carbonate factory will shut down. So, based on this we can think of two contrasting transgressive conditions, two contrasting scenario during the transgression in any carbonate platforms. One is the slow transgression. So, when we are talking about slow transgression, that means the slope of the base level curve is gentler. The rate of rise of the base level with respect to time is low, and that is associated with internal cycles of carbonate successions which do not interrupt the production of carbonates. So, this kind of scenario is called as a slow transgression, and the reverse of that is the rapid transgressions, when we get commonly the terminal cycles of carbonate successions which can lead to the drowning of the carbonate platforms and the change from carbonate to the clastic systems. So, what happens during the slow transgressions? So, basically we are looking in, say for example, if this is the base level curve. So, when we are talking about the slow transgression, we are talking about this kind of transgressive phase where the rate of rise of the base level is low, but it is overpacing the rate of sediment accumulation or sediment supply. So, this particular kind of scenario comes under the slow transgression, where accommodation creation and the rate of platform growth, they are trying to maintain a balance where continuous carbonate production is going on, and we commonly get a catch up phase. So, this particular phase is called as a catch up phase. The earlier one during HST was the keep up phase. So, what is the overall basinal condition during this catch up phase? So, at the end of the low stand and the falling stage systems tract, we know that in the platformal part it is a karstified surface which is available. Now, if I come down to the self edge, there we may have a very narrow platformal zone formed over here, and in the deep basinal part there can be some other chemical deposits formed. So, this is the scenario, this is the condition or platform available for the deposition of carbonates at the start of the transgression. Now, from here the base level was somewhere here, and from this position now the base level is rising up in successive phases. So, for this kind of rising up condition, what we can expect, again this entire area will be covered up and there will be accumulation of sediments. So, what kind of accumulation we expect? In this part, in the marginal part towards the landward part, we will get again a peritidal condition, to develop. In the middle part, what we can expect is a subtidal condition, and in this area, in the self edge area or towards the outer side, we commonly expect formation of some reef or we can get deposition of or formation of some shoal. So, when this kind of reefs are developing, they act as a barrier for the incoming water, and as a result of this kind of reef, this entire area becomes a very low energy zone, most kind of obstructed area, restricted area, and commonly they can form a lagoon over here in this zone. That lagoon may be affected by these tidal currents. So, tidally affected lagoons, and in many conditions within these lagoons we can get deposition of evaporites. Also over here, if the reef is not present, what we can expect, storm activities are going on over here, and that can lead to shedding of sediments into the deep basinal part. So, what we can get here is slope sediments deposited over here, and those are mostly by the shedding process. But in this kind of condition, the amount of slope sediments available will be much thinner in terms of their overall thickness. They will be much thinner if I compare that with respect to the HST condition, because in the HST part the supply of sediments were higher in this area. In the transgressive part, the supply is much less. So, this is the overall scenario during the slow transgression process, and this can continue for several times, this can repeat for several times. So, if I look at the overall base level, say for example like this, maybe it can go on like this, it can go on again like this. So, for each of these phases, where the rate of rise of the base level is relatively low with respect to the amount of sediment accumulation, the rate of rise is overpacing the rate of accumulation of sediments, but the overall rate is significantly low when we compare this with a base level curve, say for example something like this. So, this kind of rise is definitely a rapid rise, and the transgression will be rapid transgression, whereas when you are looking into this kind of scenario, this is a slow transgression, and in this kind of condition it is a catch up phase for carbonate deposition across the entire carbonate platform. In contrast to this, when we look into the rapid phase of transgression, so again we are referring back to that base level curve. So, we have seen so far, maybe after this we can have a transgression like this, a rise of the base level like this. So, this phase is indicating a very rapid rate of rise of the base level, and definitely during this phase the rate of creation of accommodation will overpace the rate of production of carbonates, rate of accumulation of carbonates. So, in this kind of scenario what we can expect, again if I look at that particular surface which was available at the end of forced regression as well as the low stand systems tract in carbonate depositional condition. So, over here the base level was somewhere here at the end of this phase, and from here the base level is rising up at a very high rate, very fast. So, what is happening now? In this kind of scenario we can get first deposition going on over here with this first phase of rise, and along with that we can also get some erosions going on over here, and that erosion will supply sediments into this zone. But before that erosion starts, this area is under significant depth. So, as a result of that, this rise in the base level is causing the fatigue zone to go towards the upper side, and this zone is now devoid of carbonate production. So, there is again a shutdown of the carbonate factory, So, that shutdown will start from here. At that time maybe we can get some deposition going on over there by the time the base level is rising up over here. So, this area is now under the shutdown, and a new deposition will start over here in this area. For the next phase of rise, as the depth is increasing, we get a new phase of deposition over here, and in that way we get gradual backstepping of the platformal deposits. Now, when this process is going on, this area is either going through no deposition as it is under significant water depth, or maybe it can have some instability in the form of some storms, maybe some gravity flows, and that can shed some sediments over here in the form of clastic carbonates, and that can get deposited in this phase as a healing phase deposit. This is the same kind of healing phase deposit that we have seen in case of siliciclastic succession, siliciclastic basins, similar kind of healing phase deposit that formed during the transgression. So, when this process is going on, what we are getting over here? We are getting a major surface, that surface demarcating the end of carbonate production. So, that surface over here is this one, then it is coming over here, then it is coming over here, then it is coming over here, it is going on like this. And in this part, that particular surface was somewhere here, that particular surface was here. On that, these healing phase deposits are forming, because healing phase deposits are not like forming under the photic zone, they are just supplied by reworking process. So, this particular surface, as we have discussed in our previous lecture also, so this is the drowning unconformity. So, during this phase there is a complete shutdown of carbonate factories and we get a drowning unconformity to form across the entire basin, or at least in the major part of the basin. So, deposition is only confined in very narrow zones in the platform, and that is more or less a kind of backstepping pattern. So, within the context of carbonate sequence stratigraphy, this concept of drowning, this refers to a very special situation where the transgression follows the high stand without an intervening stage of base level fall, and this is in contrast with the concept of flooding, because in siliciclastic system we have seen that at the end phase of transgression it is a flooding, and during the flooding sediments are supplied and they are accumulating, forming on lap depositional pattern. In this case, in the carbonate system, it is a completely different scenario. Here, with deepening of the water, we do not get accumulation of the basin floor or accumulation of the carbonate platform. Here, as the deepening is going on, that will shut down or stop the carbonate production. So, this is a completely different scenario if we compare this with respect to the siliciclastic systems. When you look into the slow transgressions, that can create some extra accommodation across the entire carbonate shelf, and that may result in the creation of or production of the shallow water subtidal depot zones, which may form between the shoreline and the rimmed shelf edge. These depot centers, these individual sub environments, for example the lagoon, for example the different subtidal or intertidal peritidal conditions, they are commonly of very low energy condition, as they are getting protected from the open sea by the distal self barrier reefs. So, this kind of reefs they will grow during the slow transgressive phase. The formation of barrier reefs in the distal region of the continental shelf during this slow transgression may be controlled by a combination of several factors, which may include the pre-existing karstic topography, where certain areas are closer to the shelf edge and they are having less exposed to the dissolution process during the previous stages of forced regression, and maintaining a higher elevation, and that can be the trigger, that can be the base for the formation of this kind of reefs. Or there can be the distal locations which are relative to the source areas of clastic sediment, and that is why they can get more supply of carbonate production, which can develop build up of the reefs. Or there can be the proximity to the active low stand carbonate platform, where during the low stand carbonate production was going on, and that can develop some positive structure, some elevated structure which can further grow on as a reef structure. So, when the self is flooded during this slow transgression, the relatively low rate of base level rise may allow the distal self reefs to grow to the base level. They will try to maintain that balance and they will try to keep up with the newly created accommodation. So, in the reef area we get a very high rate of accumulation. So, no water deepening in the distal self reef regions during the transgressions. At the same time, the rest of the carbonate platform, they are submerged, but with water depths within the limits of the floating zone, they will continue deposition of sediments, they will continue production of carbonates and their accumulation in different parts, starting from the lagoon area, the intertidal, peritidal and subtidal zones. This particular condition allows the carbonate factory to survive through the transgression process, and when the carbonate factory is surviving, the production of carbonates continues until it is finally catching up with the rising base level, and then they maintain the keep up phase, they maintain the balance during the subsequent high stand condition. So, overall what we can understand here is a transfer of the carbonate sediment from the self to the deep water environment can occur during the slow transgression, because during that phase when the sea level is gradually rising up, we can get some sort of imbalance produced at the self edge that can lead to sediment supply to the slope area and also to the basin floor area, and the formation of high stand setting is commonly depends on the availability of the accommodation on the self top, which traps most of the carbonate sediment, leading to relatively lesser thickness of these slope deposits. So, when we compare this with respect to the high stand setting, their thicknesses are relatively less. Now, if I compare it the rapid transgression process, they are commonly associated with high rates of base level rise, which result in the drowning of the carbonate platform, the process that we have just seen in that particular diagram. So, water depth exceeds the photic limit and that shuts down the carbonate factory. Where these rapid transgressions follow the stages of active platform growth across the continental shelf, the transgressive platforms can represent, can display characteristic backstepping geometries, because as the base level is gradually rising, the position of the photic zone is gradually changing and it is backstepping. So, it becomes progressively narrower with the process of drowning. As the carbonate factory is shut down on the platform top, this also disables the delivery of new carbonate sediment to the deep water environment through this shedding process, and the drowning unconformities have a basin wide development starting from the deep basinal part to the entire platform, and we can mark this one, we can identify this one in the sedimentary successions. The overall drowning process represents the final stage in the evolution of a carbonate platform prior to, before returning to the clastic dominated environment. This already we have discussed in our class on the drowning unconformity. So, after this drowning unconformity, after this rapid transgression, we get the HST, and during this phase clastic dominated environment, they will return back, they will come back into the system and they will produce their own characteristic sediment packages. So, once the platform is drowned below the photic limit, filling of the available accommodation during the subsequent high stand normal regression can only be achieved through some siliciclastic progradation process, which is the characteristic of the next high stand succession, producing high stand prisms and condensed sections like the normal siliciclastic system. So, when we look into the sedimentary processes during the drowning event, this can resemble the overall clastic depositional pattern and a very low sediment dispersal in the self area in a clastic system. So, in the clastic system we commonly get a condensed section. So, there the supply of sediment is much less. So, this similarity, this resemblance can be most commonly observed when we look into the distal self area or deep water part in the clastic system, where we get this kind of condensed section, and also we can compare this with the drowning unconformity formed across the entire basin in the carbonate systems. So, this can lead to some hydraulic instability at the self edge, which may be caused by rapid base level rise, and that may result in the erosion of the self edge region and the formation of heeling phase wedges during the transgression, and that onlaps the continental slope, just like we have seen in case of a clastic system, where along the slope we get heeling phase deposits, the slope aprons, transgressive slope aprons. So, exactly similar kind of deposits can form during the late phase of transgression, and these sediments are the reworking of the self edge sediments. These heeling phase wedges, they commonly consist of fine grained carbonate sediments, and they accumulate in gently dipping layers with an angle of repose which is relatively lower with respect to the seaward slope of the carbonate platform. The formation of the heeling phase wedges is commonly observed in case of unrimmed carbonate shelves, because there the reworking by these storms, by these self edge processes is possible, is common, but it can be stopped, it can be inhibited where the self edges are having a reef, because the position or occurrence of a reef will block the sediment transfer into the basin. And maybe there are certain cases where the self area is going through some starvation in terms of carbonate production as the base level has risen up. So, the starved self sea floor, that can go through some induration process, through some marine cementation during this drowning, and such cementation can lead to formation of a hard ground which can prevent the erosion of the self edge, thus not supplying sediments into the heeling phase deposit in the slope, as well as they are occurring as a hard ground within the succession. So, formation of this kind of hard ground has a two-way significance. They stops supply of the heeling phase deposits towards the deep basinal part, as well as they indicate the drowning effect, they indicate the cementation process because of non-supply of sediments, non-production of sediments or carbonates onto the self area during this drowning process. Though the drowning unconformities are always placed at the contact between the carbonate faces below and clastic faces above. This already we have discussed also in our class on drowning unconformity. This also we have seen during our class on the HST. So, always we are putting this as the boundary between the clastic phase during HST and the underlying carbonates formed during the TST. So, this kind of scenario is typical of the carbonate platforms which are attached to the mainland. So, when this HST phase is appearing after the drowning unconformity, when the carbonate factory is shut down, then from the mainland siliciclastic sediment supply is going on. So, those clastic sediment supply is available following the stage of drowning. But there can be isolated carbonate platforms which are completely detached from the mainland, from the continental part, and they lack a source of clastic sediment supply. So, in such condition, when a drowning unconformity is forming, the sediment supply is stopped, and they are not getting sediment supply from the mainland in the form of clastic sediments. So, as a result of that, what we are getting, again the sedimentation will start during the next phase of HST when carbonate production starts. So, when the seep floor again reaches to the photic zone, we get again a carbonate deposition over that drowning unconformity without an intervening stage of clastic sedimentation. So, it is not always true that a drowning unconformity should be separating a clastic system above and a carbonate system below. There can be carbonate systems above and below the drowning unconformity. In such cases, the drowning unconformities may occur within the carbonate phases. Then the question arises over here that in such condition, when you have carbonate above and carbonate below, how can we distinguish or identify the drowning unconformity? The answer to this question is identifying the hard grounds, because when the drowning unconformity forming in this kind of condition, the seep floor will be hardened, will form a hard ground through cementation process as new carbonates are not produced. So, in such condition, we commonly expect a hard ground in between the carbonate succession, and that will lead to an evidence in support of drowning unconformity formed in between the transgression and the consecutive high stand regression. So, with this I will conclude this particular discussion, this particular lecture. So, in this particular lecture we have tried to understand about the different aspects of the transgressive systems tract that can occur in a carbonate environment and what are the resultant distribution of different depositional systems. So, the scenario becomes different depending on the rate of rise of the base level, whether the transgression is slow or rapid. If it is a slow transgression, we can have a catch up phase when carbonate deposition continues throughout the entire transgressive phase, or it can be a shutdown condition, shutdown of the carbonate factories when the rate of rise is very high, when the transgression is very rapid, and we can get a drowning unconformity. We have also discussed about how to identify this drowning unconformity in different scenario. So, with this I will conclude this particular class, and these are some of the references that you can go through for further reading on this particular topic. Also, with this particular lecture we have reached the finishing line of this particular course. So, it was really a very nice experience interacting with all of you during this course. I hope that you have enjoyed a lot, you have learned many things, I hope so. I wish that this course be useful for all of you, both in your present and future academics as well as in your professional career. So, all the best from my side. I would also like to thank you for joining this course and being with me throughout this journey, throughout this particular course and following my lectures. So, thank you everyone.